Hi, I'm Don Taylor with the Tennessee Division of Underground Storage Tanks. This video is the second in a series that the division has created about pressurized piping. The first video is a basic introduction to the fundamentals of pressurized piping. If you need a general understanding of pressurized piping, we suggest you watch that video first. This video will describe line tightness testing, line leak detector testing, piping interstitial monitoring, and impact valves. Small leaks can be big problems because product in the pipe is under a lot of pressure. One way to find small leaks in piping is by doing a line tightness test. A technician puts pressure on product in the line and watches for volume changes with special testing equipment. If there are no volume changes in a short period of time, the tester passes the line. Here the technician connects his testing device to the test port at the shear valve. Depending on the testing equipment, a liquid or an inert gas can be used to pressurize the line. Now the technician begins to calibrate his testing device. The technician begins to pressurize the line to begin the test. The technician must monitor pressure and take readings over a period of time and record these readings on the division's test form. If the technician determines there are no problems, the test is complete and results are recorded on the division's test form. Another thing that is typically done when lines are tested is testing the line leak detector. The testing device can be used to simulate a piping leak greater than 3 gallons per hour. If the leak detector is tripped and restricts flow in the product line, the leak detector passes the test. Remember, if you use line tightness testing to meet the requirements for periodic leak detection, you must test the piping and the line leak detectors at least once every 12 months. Like mechanical line leak detectors, electronic line leak detectors must also be tested annually. When electronic line leak detectors are tested, it is important to have the tester verify that it is programmed properly. For example, some electronic line leak detectors can be adjusted to deactivate the submersible pump in the event of a catastrophic leak. These devices must be programmed to shut down the submersible pump at leak rates greater than 3 gallons per hour. If this feature is disabled or improperly set, the piping has no catastrophic leak detection. This could result in a large release of petroleum into the environment. Interstitial monitoring is another method that can detect small leaks and is used when piping has secondary containment. This means product is contained within 2 layers or walls separated by an open space. Interstitial monitoring looks for product between the 2 walls of the piping. This space can be monitored by vacuum, a liquid, or in most cases by electronic sensors. This is a typical electronic sensor used in sumps to detect liquids. Placement of the sensor is very important. The sensor should be placed in the lowest part of the sump so that any liquid can be detected in the shortest possible time. As you can see, this sensor is not located in the lowest part of the sump, and it could not detect a leak until the sump has collected a considerable amount of liquid. This is not considered proper sensor placement for leak detection, and this sensor should be placed into the proper position. Whenever a liquid is detected in the sump, it sends an alarm to a console which may sound a buzzer or flash an indicator light or both. The alarm should alert an individual that a liquid has been detected in the sump and that some action should be taken. The liquid may be fuel or water, but it is important to know which, since there may be fuel leaking into the sump. Another thing to pay close attention to is the crash valve, also called the impact or shear valve. The impact valve is located here. This is a very important safety feature for piping and is intended to shut off product flow in case of a vehicle collision with the dispenser. In order for this crash valve to function properly, installation codes require that it must be securely anchored under the dispenser. Make sure that the crash valve is securely anchored, and if not, call a service company immediately to secure it for you. We hope this video has been helpful, and if you need a basic understanding of pressurized piping, we encourage you to watch the first video in the series, which gives a brief overview of pressurized piping. Please check the Division's website for other helpful videos to help you with underground storage tank system compliance. I'm Don Taylor with the Tennessee Division of Underground Storage Tanks.